Activity on Enceladus was first detected early on by the Cassini spacecraft using a bunch of different instruments. It was first noticed by some very strange magnetic field signatures in the vicinity of the moon, but later there were very spectacular pictures taken by the spacecraft when it looked at the dark side of the moon. It saw this beautiful plume of particles emerging from its south pole. And so
what is in those plumes of material that are shooting out?
the primary constituents are basically water vapor and very small grains of water ice that are maybe, say, 1 to 10 microns across, so like roughly the width of a human hair.
And what do we think is going on under the surface of Enceladus to actually lead to a spray of water issuing out into space?
That is still a bit of an open question. Many people would like to think there's a reservoir of liquid water underneath that's basically, venting into space through very tortuous small cracks. But, there were other ideas that it was some sort of process where solid goes to gas directly. But many people are excited by the possibility there could be liquid water under the surface, in which case something must be heating the interior of Enceladus.
So how could Enceladus, given it's so tiny, actually be generating this heat then?
The way this could work is tidal forces are basically difference in forces across the moon. And the best example of this is in the Jupiter system with the moon Io. As Io goes around Jupiter, it feels very intense tidal forces from Jupiter, and these cause the moon to actually be pulled and stretched in various directions. And that kind of kneading of the moon can generate significant amounts of heat.
So the model would be that as the moon Enceladus goes around Saturn, it's experiencing changes in gravitational forces from Saturn, and this is pulling or pushing on the moon, and that is leading to some kind of frictional heating inside.
More or less, yes.
So what did you then do to really add some clarity to what we thought was going on?
So what we did was we looked at data from one particular instrument on Cassini that could take pictures. And what we found was that if we corrected for how bright the plume appeared, we found that the plume was always systematically brighter when it was in the point in its orbit that was furthest from Saturn. Enceladus is not on a perfectly circular orbit. It alternately gets closer and further from the center of Saturn. And we found that every time it was furthest from Saturn, it was brighter, and when it was closer to Saturn, the plume was fainter. And so we think that this is the first direct detection of some connection between the activity in the plume, the amount of stuff coming out of the moon, and tidal stresses on its surface.
So if we were to put your observations together, at the point where it is furthest from Saturn, is the moon experiencing the greatest degree of tension, stress, and would that effectively open up those cracks on the surface to allow the plume to issue? Does this fit together?
Yes, that exactly is what's going on, or at least what we think is going on. The various people who do the models of these forces do say the cracks should be under the most tension. They should be pulled apart the most when Enceladus is furthest from the planet, and they should actually be pushed shut when Enceladus is closest to the planet.
Those cracks from where the plume comes are down at the South Pole, the bottom end of Enceladus, aren't they? Why just there?
That is also a very good question. There are some discussions that think if you have a reservoir of liquid water or warm ice, it changes the density of the region under the surface. And it could be that basically the moon will tend to reorient to place that low-density region at either the South or North Pole. But that is actually something that people are still trying to study at this exact moment.
So now you have all this wonderful data, which seems to suggest that the original theory is right, that there is some kind of tidal kneading of the moon which makes it hot, and this melts some ice and puts it under pressure, pulls open some cracks, the whole thing jets out into space. What will this now enable space scientists intrigued by Enceladus to be able to do?
What we have shown is that tidal forces are affecting how open the cracks are. They're going from being pulled open to being slammed shut. This supports the idea that Enceladus is being kneaded by tidal forces. But now the question is going to become, is this sufficient to power the plume? Is the amount of heat we're actually generating doing that? in principle, by seeing these sorts of variations in the amount of material, we can get a fairly decent estimate of, if there are liquids at depth, just how responsive is the moon to these sorts of perturbations. And that should help us better understand what's actually going on beneath the surface.